So yeah, hi, I'm back. My name's Steve. I'm with ODOT. I have Garrison and Andy here with me for this presentation. So they are GIS developers here at ODOT, and they work primarily on our asset management data collection program. So we call it our collector program still, because old habits die hard. But go ahead, next slide, Garrison. So Michael, who is another ODOTer, had a presentation about an hour ago that touched on the collector program. So I'll try to keep it brief, but a little bit of overview. We've been doing this for about 6 years now, and we have over 1,000 users collecting data out in the field for 14 assets, 14 different transportation related assets. So the program itself, the primary goal is that mobile asset collection out in the field, but we're also building web mapping applications, dashboards, and reports to kind of supplement that data collection. And we have quite a robust process to kind of build out these solutions. So Michael's team, who was on the presentation earlier, they go through and build a very, I guess, detailed set of requirements, working with the business units, pass those requirements along to our team, who we're the GIS folks. We build out the technology, do some testing. So we have some extensive QA, QC testing, and then we actually do user acceptance testing too, to run these solutions by our end users. And then deployment and then production support. So that's kind of a large lift when you're talking about that many users across the state and 14 different assets. So you can go ahead to the next slide, Garrison. So this is kind of a screenshot of the different assets that we have in production. If there's a phase like phase 2 or phase 3 next to that, that means that we've gone through some major enhancements. So we're doing like 2 to 3 of these a year over the last 6 years, where we're doing major enhancements or implementations of these assets. My screenshot here of the asset inventories is a little out of date. I think Michael said there's over 1 million asset records, asset inventory records. And then on top of that, we have another 300 something thousand inspections that go along with those assets. So there's a lot of data, a lot of useful data that ODOT's collecting through this program. Go on to the next one, Garrison. And so a little bit of background on our technology stack. So I mentioned in my previous presentation that we're still using ArcGIS for server, branded ArcGIS Enterprise. We're just using components of that enterprise system. It really kind of revolves around that SQL Server database, though. We're using a SQL Server SDE on-prem. And then all of our services are being pumped out through ArcGIS Enterprise, and we're consuming that data in ArcGIS Online. So that's kind of the medium where we're publishing out all of our web mapping applications. This area over here on the left, though, this is kind of the meat and potatoes of what we're going to talk about today. And I guess go on to the next slide, Garrison. I think I have this. Yeah. So since the beginning of this program, we kind of identified early on that we needed a way to automate data input. So we needed to make it easier on our end users who are collecting data to not have to repetitively put in that this point lives in Franklin County, or here's the linear referencing, the LRS that this asset is tied to. So those are some very basic, I guess, data automation wins that we got early on, but slowly we've started to build out our automation using Python, Model Builder. We're using FME now, Windows Scheduler, and geoprocessing widgets to kind of bring it all together. So Garrison's going to talk a little bit about the automation that we're doing as far as standard attributes, some data processing, and then Andy's going to talk a little bit about a recent project that we did where we're automating location tracking, which is very interesting stuff. So I'm going to pass it over to those guys.
Awesome. Thanks, Steve. So my name is Garrison Gawel, and I do a lot of the Python scripting that we do. So just kind of want to talk about what are some of those components that we use and we leverage in order to do the things that Steve was talking about here. So really what we're doing in these Python scripts, we're using Python and using that as kind of the bare bones and skeleton for the script. And then within that, we're using different, if else logics, things to do, perform different calculations, check other fields. We use different ArcPy tools to do some more advanced things with edit sessions, as well as using SQL statements to kind of do some mass updates and do lookups of different values and stuff from other tables and services. And so once we have a script written and built out with everything that we want to do, we make a model, we put that script in the model, and then that's how we run that actual script to update the data. And from this working model, we can then publish that up as our geoprocessing service. And then once that's published, what we do is we get that scheduled so that it runs nightly. So we have a large list of different scripts that all run an updated data set, and then we'll produce different reports depending on the need and requirements for the business. So just want to run through some different examples of what these components look like here. So a couple of the Python examples we use, a big one is, we need to figure out, okay, which data needs to be updated and take a look at. So a lot of times what we're doing there is we're just using a basic search cursor with, some SQL strings in there as our requirements. And in the example here on the top, the big thing that we do and we have to think about is we archive our data sets. So we have to think about that. So there's a couple of requirements here. So one, we're looking to make sure that we're only, updating our records that haven't been archived. So that's where our GDB2 date comes in. And then also what we use is a system updated date field. And so as these things and these records are updated, we populate that field with the timing. So in this case, what we do is we look for those active records and where that record system updated date is either null or the last edited date has changed and is greater than that system updated date. So with that cursor, we can then grab all those records we need, and we can use a for loop and just run through that loop and pull every bit of data that we need to work with or reference in some way. And then along with that, we'll also build custom functions in that we need to do certain things. So a lot of times it's, hey, we're going to make, we have this requirement of we need to check whether this asset or, for example, a sign support is located along, an interstate route, or if that's located along, a county road or a local road, or if it's on a ramp. So with that, we'll create our own kind of little custom written functions that we can use and then copy and move across the scripts so that we're not kind of reinventing the wheel each time. So in this little example here, what we could see is, we're telling the program, hey, do some if else logic here and figure out, okay, if it's designated as a state route, all right, cool. Then we're going to go ahead and we're going to use a different LRS to properly populate and get that route information out of it and where it's located along that route. And in this case, we kind of have a waterfall that goes down here looking, at the state route. And then if it's, something such as a ramp or a local route in that way. So a couple examples here, we use ArcPy tools that are natively built in from the ArcPy module, and just usually geographic calculations kind of stuff. So for example, looking for latitude, longitudes of points and whatnot. We're going to use that latitude, longitude and help pass that through. And that's going to help us get, okay, where our route is from the LRS, as well as that kind of mile point that's on it. Another common one that we've started to use is more editing sessions, and it kind of depends on what's being done. So with a recent project, we had a requirement where a user could go in and they could mark a sign support as having been replaced. And doing that within the script, we've written a function that works and uses an edit session here. And by opening that edit session, we can go through and use another kind of cursor. And with that, create that new record, apply all the old attributes that are still common to it, and then retire the old record and still keep it archived within there. And then another one that we use, we deal with cable lengths as well, barrier lengths. So there are things in which we want to make sure that we can calculate properly what those lengths are in the appropriate units, especially and take into effect the geographic location as well in that projection. And then one of the final ones that we use a lot is these SQL statements. So we have several things that we need to do as far as a geographic join essentially, or a spatial join. For example, we want to know, hey, if we drop this point down somewhere within the state, that we can get that county information and then what ODOT district that county is a part of. So in this top example here, you can see, we're just running, it's a pretty basic SQL statement of just an update, and we're just doing a spatial join where that shape intersects and saying, hey, for all of these records that we've determined based off of our SQL queries and our SQL strings that need to be updated, go out and run that update for all of those records. And then the same thing kind of goes to here with when we're looking at other tables and wanting to make sure that we can pull out those different bits and make those relationships across the different tables. For example, here, looking at a query from our biweekly inspection script here, where we want to know is like, okay, if we notice there's a deficiency in the road or with one of the transportation assets that we monitor, we want to know what asset number specifically that file number for that asset is. So what we're doing in that case is, hey, we're going to say, find us the closest record based off of these different requirements or these different styles, and then take that one value of that file number from the associated asset and populate it within this other table, or select me that value and we can return it back to another function where we can do an update. And then one of the final things we really do a lot with the SQL statements here is doing updates for basic things. So in the bottom here, it's just a simple update query where we're saying, hey, set the inspection due and the maintain recommend to these values here that we've gone through and calculated already in our logic in the script, and then run that. And so that'll commit those changes into the database itself. And then one of the new things that we've started working with recently here is feature manipulation engine, or FME. Very powerful tool with, it has a more of a graphic user interface, can kind of move things around, drag and drop, play with things, connect things together in that way. And sometimes it can run really quickly depending on your data set, and it can also take a while just depending on what you've got going on. So two kind of little examples here regarding that is this first one, this location tracking one. That's really simple. And when you look at it, all we're doing is we're saying, hey, we're going to look at this track lines out of AGOL here, and test to make sure that they're coming out of the right apps that they're getting collected from. And then we want to compare that to the records that we already have in our own table of where we're building those track lines and monitoring them. So it'll then compare those and then say, hey, only migrate and populate new records that don't exist into this actual table that we're going to then use other processes to actually generate what we would consider the route driven records for these users as they drive. And then on the right here is a much more complicated example where we're reading off of a bunch of different spreadsheets. And what we're doing here is we're testing out some different attributes, making sure that we can properly map those onto our LRS, and then determining whether, okay, this record isn't mappable. And so we do some tests to make sure and figure out what that reason is. And then we write it out to an error report for the user to take a look at and then make their updates. If the record is mappable, however, this will go through, calculate some attributes, and then populate those records. And both of these are examples here of processes that we have set up on our FME server that run nightly. So every night these are kicked off, they run, and that's how we load and run some of our data here. And then a couple limitations to think about when you're doing data automation like this. You have to think about what limitations you have within your own database and layers that you're working with. So as I had mentioned previously, we archive all our data. So that way we can get a record of what's changed and if we've had any issues or processes gone wrong. And so it's things like that you want to think about. Okay, well, if we're archiving, we need to make sure that, we're only working with the, unarchived or the database retired records. The same thing with editor tracking. If we're running processes, we don't want to lose that user information of who's been creating and editing different records and stuff. So if we need to, we can track them down and figure out like, hey, what's going on here or something like that, or quality control an issue. And then finally, one thing to really think about is processing time. Depending on your data set, your processing time could take anywhere from 5-10 minutes to days, depending on how large it is. And as shown earlier, we do have some data sets that only exist of, a few thousand records to our signed data set, which is somewhere close to almost 300,000 supports and over 400,000 individual signs itself in there. And then something else too is you want to think about, if you're going to automate these things, your server stability. Make sure that the scripts are allotted to have enough time to properly run when you schedule them. So you're not clogging up the server with things, not having issues with it timing out halfway through your processing. And think about, okay, how many records are we going to be updating on average every night? There's a big difference between running a script that's going to update 1,000 records versus one that's going to update about 100 or so. And then lastly, something to think about is, is that server healthy? Is there anything limitation wise on it? Is it getting too full of processes and data that it's having problems and struggling? Is there a corruption issue? Is it up to date as far as the versioning and everything? So just some things to think about as you go forward and trying to automate data and that updated and processing. So cool. So I'm going to go ahead and pass it over to Andy here, and he's going to go ahead and talk about this recent project that we did regarding location sharing.
Thanks, Garrison. So yeah, we're just going to kind of go over an example of how we use all those things Steve and Garrison have just talked about. So one of the things we decided we needed was we wanted to be able to track where our users are in the field when they're doing inspections. We have a need to do inspections every 2 weeks on all of our state routes. So we wanted them to be able to see what routes they've driven and how long ago they've driven them, and then see what routes need to be driven soon or right now. So to do that, so I got to get Garrison tracking information, so then he can take his FME process and then create a SQL table for me, and then a feature layer that we're going to bring back into the map. So to do that, we need to set up our map for location sharing. So we open up Field Maps Designer, and in the settings, we turned location sharing to required. Now we use required. You don't have to use required. We could probably just turn it on or off as you please, but we wanted it so when they open the map, they had to turn on location tracking. That way they couldn't forget. And then below that, we're going to set a category. Now we want to set a different category for each field maps deployment that we're using, and that way we can filter and group those later. Okay. So this is the FME that Garrison was just talking about. So once we turn the tracking on, the track lines is the first part of that. And then he takes it and does his magic. And then he gives it back to me in the SQL table way over there on the right on the end. Now, Garrison, you just go to the next slide. Okay, and then this is what we end up with. We have categorized tracking data that's spread out across the state. We have our 3 categories: biweekly, MCR, QAR. Those are different inspection apps that we have created. And then we can also track by user, date, things like that. So this is just the raw. So this is the tracking data that goes from field maps to FME to SQL. Now we put it back on a map. And then from here, we're going to want to refine it some more and get the actual routes driven, and then the dates and further from that. So if we go to the next slide. So in order to that, we're going to use a model builder model. And these are the tools that we're going to go over. And then the next slide, it'll show the actual model. So we need select layer by attribute, locate features along routes, make route event layer. Then we append those, and then we're going to do a calculate field. And I'll go over each one of those steps in the next slide here. Okay, so this is the model itself. So the biweekly, on the top left there, we have the biweekly location tracking that Garrison provided with his FME processes. And from there, we're going to select all of the new records. Now we do that because we have a field called like system updated date. So all of the empty system updated dates, we're going to select those and then create a selection table off of those. If it has a system updated date, we won't select it. That way we're not just stacking over and over. We're not making copies. We're only getting fresh new data every single time. So once we have our selection table, we do locate features along routes. Now this is where we link that back up to our linear referencing system, and we have our state routes and ramps there so we're going to locate all of the tracking that goes along that. So when they turn the tracking on, they're going to be tracking on routes that we're not necessarily inspecting, and we're not interested in collecting that information. We only want the state routes while they're inspecting them. So we're only going to locate any tracks that are within a certain margin or radius from our linear referencing routes that we want to use. So once we do that, that creates a table. And then that table has your route information, your beginning and end mile point, and then any other information that we need. And then from that table, we run the make route event layer tool, which essentially just makes a feature layer, puts it on the map. So it takes our beginning and end, and then it compares them back against that linear referencing system that we referenced earlier. So once we have that event layer of all these new routes that have been driven, we're going to want to append that to our route driven table that is our cumulative record of all the routes that have been driven forever, categorized by user and then categories. So we append those new records into that table. And in the append tool, we have like a field matching so that we make sure that we bring in all the correct fields over from the location tracking. So the user, the date that it was driven, things like that. So once we append that, now we have the new appended routes driven, and we're going to circle back once that's done to our selection table where we selected all the records that didn't have a date. So we go back to that selection and we run calculate field where we add the date, today's current date on there. And that way, when we run it again, we only get fresh new records every single time. Okay. So this kind of shows you the raw data on the left, well, the semi-raw data, right? And then our biweekly tracking information on the right. So, and then we change the route color designation by how long it's been since they've driven that. And that's also an overnight process where we just subtract the days. So if it's green, they've done it within a week. If it's yellow, it's been over a week. And if it's red, it's been over 2 weeks. That means they need to get out there and drive those routes again. And then once they drive the routes during the day, we run our processes. And then the next day they'll open up the map and all the routes they drove will be green now. A couple of things that we've noticed, some limitations or things to consider, we'll say. So device behavior. So everything kind of works differently. iOS versus Android, they kind of function differently. And tablet versus phone is going to function differently on how they actually track you. So sometimes the tracking will stop if the screen goes blank, and sometimes it won't. It just really kind of depends on what kind of device you're using. So it's just something to be aware of. So we have everybody using the same device, so it's not as big of an issue. But if you had Android and iOS devices, you would just have to be cognizant of the differences. Another thing to consider is battery usage. It's definitely going to drain your battery much faster out there in the field. So just keep it plugged in as much as you can. And then one thing also we notice is field maps account sharing, which we shouldn't be doing anyways. But if two people are logged in the same account and they're using this app in 2 different areas, the computer doesn't know, and it'll connect those 2 locations together and gets us faulty information that we can't use. And one other limitation is the tracking does not turn off automatically if you back out of the map that you open that requires tracking. So we have to do training and documentation to let them know best way to end the tracking when you're done. I suggest that they just turn off tracking while you're in the map, and then it will force close the map, and then you don't have to worry about it. So that's all we have for that. And time for questions.